Okay, on this problem, we're asked to write a logistic equation with the following perimeter values. Then solve the initial value problem and graph the solution. Let R be the natural growth rate, K the carrying capacity, and P sub 0 the initial population. Okay, so we're given that R is equal to 0.3, K is equal to 400, and this initial condition, P naught, is equal to 20. We could also write that that's 0, 20. Okay, that's your initial condition, T, comma, P of T. Okay, that'll come in later. For now, let's plug in what we have here. Okay, so we're given this general form of a logistic equation right here. So we're going to plug in the R and the K. So I get, let's change that into dP over dt. So dP over dt, which is the same thing as P prime of T, is equal to 0.3 times P times 1 minus P over 400 for K. Okay, so we're not going to put in the 20 in here. That's going to come in later because this is an initial condition. This is a variable P. Okay, so we need to separate this thing and turn it into an initial value problem. So I'm going to multiply the dt to the other side, and I'm going to divide all this stuff back to the left side. Okay, so what I'll end up with is 1 over P times 1 minus P over 400 is, and that's going to be dP, because I'm separating these two, equals 0.3 dt. Okay, so now that we've separated them, got all the variables on the same side, let's integrate. Okay, so this side integrating is pretty easy, right? But this side is going to give us some complications. So let's take a look at this side. What I'm going to do on this side is I'm going to split it up using partial fraction decomposition. And what that means is that I have, let me write this in a different color. Okay, so partial fraction decomposition for this particular problem, I'll have 1 over P times 1 minus P over 400. I'm going to set it equal to A over P, it's this one, plus B over this one, which is 1 minus P over 400. My job now is to figure out what is A, what is B. Okay, so how I'm going to do that is I'm going to multiply this denominator by everything. So if I multiply this denominator, let me write that right here. So P times 1 minus P over 400. And then also times these, P times 1 minus P over 400, and P times 1 minus P over 400. Okay, so if you see here, it's the same on top and bottom. This cancels, and you're left with a 1 here. Okay, on this one, the P cancels, so you're left with A times 1 minus P over 400. And on this one, the 1 minus P over 400 cancels, and you're left with BP. Okay, let's multiply this out so you get 1 is equal to A minus P over 400 plus AP over 400 plus BP. All right, so what you're looking for on this, on the left and the right side, any terms on the left side that have a variable P in them will be set equal to these two. There are none. Okay. Any terms over here that do not have a variable P in it, there's one right here, will be set equal to the only thing over here that does not have a P variable in it. So you can see that 1 is equal to A, right? 1 is the only thing without a P on the left side. A is the only thing without a P on the right side. So A is equal to 1. Okay, so already figured out part of it. Now for the other term, since there's nothing over here that has a P term, you have to put a 0 equals, and now we're not going to write the P, we're just going to write the minus A over 400, negative A over 400, plus B. I'm going to sub in a 1, so 0 is equal to negative 1 over 400 plus B, and as you can see, B, when I move this term over, is equal to 1 over 400. Okay, so how does that help me rewrite this problem? Well, I have my A and my B, and remember it was like this, A over P plus B over 1 minus P over 400. So that would give me that 1 over p times 1 minus p over 400 is equal to 1 over p instead of a over p plus 1 over 400 over 1 minus p over 400. That's the b. Let's clean this up because this is a complex fraction, so I'll multiply the top and bottom by 400. 400 there, 400 there. Okay, so that will get me 1 over p plus 1 over, distribute this, 400 minus p. Okay, so that's what this turns into, is this, using partial fraction decomposition. All right, so that was a little aside, a little reminder on the partial fraction decomposition, but we're going to write this integral as 1 over p plus 1 over 400 minus p dp equals the integral of 0.3 dt. Okay, so now I can go ahead and do this thing. I'm going to split it up into 3 integrals. 1 over p dp plus 1 over 400 minus p dp equals 0.3 dt. Okay, the reason I did that is because this is going to require a quick little u substitution, but these two will not. This is ln, so you have ln of p. Don't forget your absolute value. And this, of course, is 0.3 t. I'll go ahead and put my constant over there. Okay, so for this one, we need a quick little u substitution. So let me write that out here. So if u is equal to 400 minus p, then du is equal to negative dp. So dp is equal to negative du. Okay, so the reason that's important is because it's going to change this to a negative answer. Okay, so you can write that as the integral of 1 over u, that's negative, negative 1 over u du, which becomes negative ln of u, which becomes negative ln of 400 minus p. Okay, so put that right here, plus, or I could have put minus, either way, plus a negative ln of absolute value 400 minus p. Okay, let's combine these two. Okay, these are logarithm rules. So we have ln of p minus another ln of 400 minus p. The minus sign means I can divide. Okay, so I get ln of p over 400 minus p is equal to 0.3t plus c. Okay, so there's a lot of different strategies on how to find the c. Sometimes some books and some instructors wait till a little later. I'm going to go ahead and do it now. Okay, so I'm going to go ahead and use this initial condition now, which we wrote about up here. It's right here. And plug a 0 in for t and a 20 in for p and solve for c. Okay, so I'll do that in a slightly different color. All right, so ln of 20 over 400 minus 20 is equal to 0.3 times 0 plus c. Okay, so when you combine those together, okay, you're going to end up getting, let's see, ln of 20, that's 380 on bottom and 20 on top. Okay, so that's going to be ln of 1 over 19, okay, which you can change to ln of negative 19. Okay. All right, so we have ln of negative 19 for our c. Okay. All right, so now that we have our c, we can write this problem out. It won't be in the final form yet, but let's go ahead and write it out. So I have ln absolute value of p over 400 minus p equals 0.3 t plus ln of negative 19. Okay, so what we need to do with this problem is solve it for p. Okay, so how are we going to go about doing that? Okay, well, the first thing I'm going to do is move this ln over to the other side and combine it with this one. Okay, so I'll get ln of p over 400 minus p minus ln of negative 19 equals 0.3t. Okay, we can combine these two through subtraction. It looks like I've made an error. Yeah, this should be, the negative here should be on the outside. Earlier in the problem, when I did this, ln of 1 over 19 is not equal to ln of negative 19. It's actually equal to negative ln of 19. Okay, so that changes things up. So let's go back here. We're still trying to solve that initial condition, but this is positive and this is negative. Okay, so it's minus ln of 19, positive 19. Okay, so when I move this to the other side, it becomes plus, and this is also positive. Okay, that fixes the error. Okay, so what I'm going to do now is I'm going to combine these two. Since they're adding, I'm going to combine them by multiplying. So that's ln of 19p over 400 minus p equals 0.3t. Okay, now once I do that, I can take the natural exponential function of both sides, which will cancel the ln. So if I do that, put an e here, put an e here, I get 19p over 400 minus p is equal to e to the 0.3t. Now I'm getting close, but I still haven't solved for p because I got this p here and the p here, so that's a problem. So what I'm going to do to take care of that is a quick little long division. Okay, so if I do a quick little long division here on this problem, I will divide negative p plus 400. That's this, right? Just rewrote it in different order. Divide into 19p. Okay, so what do I multiply negative p by to get 19p? That would be, let's see, negative 19. Okay, so negative 19 here, and I multiply and I get 19p. If I multiply this down, let's see, what is that? I think it's like 3700. Let's see, 19 times 400. Yeah, 7600. Okay, so multiply here, you get negative 7600. Okay, minus, plus, so you get a remainder of 7600. So it's 19 and 7600 divided by this. Okay, so that gets us, the important part about that is it gets us one variable. Okay, so this will become negative 19 plus 7600 over negative p plus 400. Okay, one variable instead of two now. Okay, e to the 0.3t. Okay, so I can move the 19 to the other side. 7600 over negative p plus 400 is equal to e to the 0.3t plus 19. Okay, and now I can flip both of these fractions. Okay, this is a fraction, there's a 1 under it. Okay, I can flip both of these. That gets my variable to the top. So negative p plus 400 over 7600 is equal to 1 over e to the 0.3t plus 19. Okay, I'm getting close. I need to multiply by the 7600 and then subtract the 400. So that's negative p plus 400 is equal to 7600 divided by e to the 0.3t plus 19. Remember, the plus 19 is not in the exponent. I may make it look like that occasionally, but it's not in the exponent. Okay. All right. And now we have to move the 400 over by subtraction. Okay. So we've got negative p is equal to 7600 over e to the 0.3t plus 19. Okay. And then minus 400. Okay, and then we just change that to a positive sign and change all the other signs. So p is equal to 400 minus 7600 over e to the 0.3t plus 19. Now, If your book or your instructor did this in a different way, they may be coming up with a slightly different answer. We can combine these, okay, if we want. Common denominator is this right here, right? E to the 0.3t plus 19. Okay, so I will multiply the 400 by that on top and on bottom, because right now there's a 1. Okay, so that will give me P is equal to 400 times e to the 0.3t plus 19 minus 7600. Okay, all over the denominator of e to the 0.3t plus 19. Okay, distribute this out and you get P is equal to 400 e to the 0.3t plus 7600 minus 7600. Okay, so the 7600 came from 400 times 19. Here's the minus. Okay, so obviously those are going to cancel out. E to the 0.3t plus 19. Cancel, cancel. Okay, so we get P is equal to 400 e to the 0.3t divided by e to the 0.3t plus 19. I like that form. That's a pretty good form, but you may go farther. Again, these are all the correct answers, right? Everything that I've been writing for the last minute or two, they're acceptable final answers. But if you want it to get cleaned up, you may have to take a few more steps. There's one more thing you could do. You could divide the top and bottom by e to the 0.3t. So if I divide the top and the bottom by e to the 0.3t and divide by e to the 0.3t separately, right, here and here, okay, that will give me 400 over, this becomes a 1, plus 19 over e to the 0.3t. And if you want to write that without having a fraction within a fraction, your final answer could be 400 over 1 plus 19 e to the 0.3t. And that's it. Let me put that negative sign there. Okay, we brought that up, it became negative, and that's your final answer.